1. Hi all, this is Raghuram Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Okay, the course name is Unconventional Machining Process and the topic is Electro Discharge Grinding Problems and Solutions. Okay, now at the end of this session, student will be able to solve the problems on material removal rate of electro discharge grinding. Okay, so this is almost similar to electro discharge machining, EDM. Okay, right. Now let us look at this non-traditional machining processes. Okay, classified as mechanical, thermal, chemical and electrochemical. Okay, in mechanical, ultrasonic machining, water jet machining, abrasive water jet machining, ice jet machining. In thermal, electro discharge machining, electro beam machining, laser beam machining, ion beam machining, plasma beam machining. In chemical and electrochemical, chemical machining, photochemical machining, electrochemical machining. Okay, so however, we have to solve the various problems of all these categories. Okay, so now we are in the stage of electro discharge machining. Under that, electro discharge grinding that we are discussing in this presentation. Okay, see here EDG. Okay, in the subsequent slides, if you find EDG, that is electro discharge grinding. Okay, now problem 1, calculating the material removal rate in EDG, that is electro discharge grinding. Okay, so in this the given data is that discharge current 12 amperes, pulse duration 100 microseconds, duty cycle 50%, that is 50 by 100. Okay, specific material removal rate C star, that is 1.2 into 10 power minus 3 mm³ per ampere per second. Okay, now calculate the material removal rate in mm³ per minute. Okay, so this is the given data. Okay, I is given. Okay, so pulse duration time is given and duty cycle 50%, that is 0.5, 50 by 100 is given. Okay, C star is also given. Okay, now by using formula, basic formula, material removal rate equal to C star into I into duty cycle. Okay, I is given, duty cycle is given and C star is given. Okay, simply substitute the given values. Okay, so that we'll get the material removal rate. Okay, so for material removal rate, we have formula C star into I into duty cycle. Substitute the values so that we get 0.432 mm³ per minute. Okay, so the material removal rate is 0.432 mm³ per minute. Okay, right. Now problem 2. Estimating power consumption in EDG. What is EDG? Electro discharge grinding. Electro discharge grinding, EDG. Okay, right. Discharge voltage is given, V is given, voltage, and discharge current I is given, and duty cycle 60%, that is nothing but 60 by 100, that is 0.6. Calculate the average power consumption in watts. Now, what is the formula for the power consumption? P equal to V into I duty cycle. Okay, so V value is given, I value is given, and duty cycle percentage is given. So simply substitute the given values. Okay, so 8 is the voltage and 15 is the ampere, that is current, and duty cycle is 60%, that is 0.6, so that we get the power consumption in watts, that is 720 watts. Okay, so the average power consumption is 720 watts. Okay, right. Now, tool wear rate in EDG. Okay, so in problem 3, the following data is given. Volume of material removed from the workpiece. Volume of material removed from the grinding wheel. So here grinding wheel and this is workpiece. In electro discharge machining also, this is grinding wheel. This grinding wheel is the tool to remove the material on the workpiece. Okay, so in order to calculate the tool wear ratio, here the tool means grinding wheel. Okay, so it is the ratio of volume of material removed from the grinding wheel, volume of material removed from the grinding wheel to the volume of material removed from the workpiece, that is TWR, tool wear ratio. Okay, so here 6/30. If we want the percentage, multiply with 100. Okay, see, look at here, tool wear ratio, TWR, volume of material removed from the tool, that is nothing but grinding wheel, okay, by volume of material removed from the workpiece into 100%. Okay, so what is the given data here? 6/30 into 100, that is 20%. So the tool wear ratio is 20%. Okay, right. Now let us discuss problem number 4. Surface finish in EDG, electro discharge grinding. Okay, average discharge current 10 amperes, pulse on time 50 microseconds, pulse off time 20 microseconds. Surface roughness constant is 0.005 microns per ampere. Okay, right. Calculate the surface roughness RA in micrometers, okay, or microns simply. Okay, right. Solution. The surface roughness RA in electro discharge grinding can be calculated using this formula. RA equal to K into I. Okay, here K is given. See, look at. Okay, what is the value? 0.005 by A. Okay, this one is given. K value, surface roughness, small k. Okay, and I is given. Okay, average discharge current. Okay, so by using that we can find RA 0.005 into 10. Okay, K and I, that is 0.05 micrometers. Okay, thus the surface roughness is 0.05 micrometers. Okay, here pulse on time, pulse off time. Have we used this information anywhere? So this is a superfluous data for this problem. But we can assess some other extended question will be given. This data can be useful for the assessment of those parameters. Okay, and don't think that this data is useful for this problem. Okay, so sometimes superfluous data will be given, so we may not use that data for the calculation of the required question. Okay, so we have to understand this superfluous data will be useful in the assessment of some other parameters. Okay, right. Next, problem number 5. Spark gap calculation in electro discharge grinding. Okay, so in an EDG process, the following parameters are observed. Okay, open circuit voltage, discharge voltage, capacitance of the dielectric 400 pf. Okay, so we have to convert this one. Okay, that is 400 into 10 power minus 12 f. Okay, so calculate the energy per spark in microjoules. Okay, micro means 10 power minus 6. Okay, so all these are basics. Okay, so open circuit voltage and discharge voltage is given. Okay, now the energy per spark E in EDG can be calculated using this formula, E equal to half CV square. Okay, so C is the capacitance of the dielectric, that is 400 pf. Okay, so already we have discussed that we have to convert that pf into f. Okay, so we have to multiply with 10 power minus 12, and discharge voltage is 60. See here, open circuit voltage and discharge voltage 2 is given. So here discharge voltage this one. Okay, so don't take open circuit voltage. Okay, now substitute in that formula. So you will get 0.72 into 10 power minus 6 joules, that is 0.72 microjoules. Okay, so finally the energy per spark is 0.72 microjoules. Okay, right. Now problem number 6. Estimating machining time in electro discharge grinding. Okay, so in an electro discharge grinding process, the following data is provided. Okay, workpiece material is given, tungsten carbide. Now the student has to focus on the workpiece material, whether this data, that is tungsten carbide, okay, is useful to solve this problem or not. Okay, and he has to think, he or she has to think whether the tungsten carbide, that is a material, okay, will be useful in the problem solution. Okay, grinding area, that is 100 mm square. Desired depth of cut 0.2 millimeters. Okay, depth of cut is nothing but height. Okay, material removal rate MRR, that is 0.5 cubic millimeters per minute. Okay, calculate the time required to achieve the desired depth of cut over the given grinding area. Okay, so we have to understand the problem clearly. Here grinding area is given, okay, and desired depth of cut is given. Okay, material removal rate MRR is given. Okay, so we need to find the time required to achieve the desired depth of cut over the given grinding area. Right. We know volume of material equal to area into depth of cut. Okay. So volume equal to area into depth of cut. Okay. So let us say this is the okay. So this much volume, let us say we need to cut. So this is the area, okay, and this is the depth. So that will be the volume of material to be removed. Okay, right. Substitute the given values. Okay, volume of material equal to area 100 mm square, that is given, and depth of cut 0.2 mm given. So we get 20 mm cube, that is the volume of material. Okay, right. Now calculate the time required to remove the volume using the given MRR. Okay, so here actually we have to usually calculate MRR, but the thing is that here MRR is given, material removal rate is given, that is 0.5 mm cube per minute, but we need to calculate the machining time. So simply substitute the values, volume of material removed, that is 20 mm cube, and material removal rate is also given, that is 0.5. Okay, so the value is finally 40 minutes. Okay, now thus the time required to achieve the desired depth of cut is 40 minutes. So in 40 minutes, the grinding area 100 mm square and depth of cut 0.2 mm can be achieved. Okay, the time taken would be 40 minutes. Okay, right. So before we close this presentation, let me summarize from the all these problems. Okay, so in the first problem, what we have to calculate, material removal rate. Okay, so C star is given, okay, I is given, and duty cycle is given. Okay, so for material removal rate, the formula is C star into I into duty cycle. Okay, so we have to just substitute the values in the given formula. Okay, right, it is very simple. Next, in the second problem, calculate the average power consumption in watts. So for power consumption, we have formula P equal to VI into duty cycle. Usually power equal to VI, but here the duty cycle is not 100%. So we have to take it into consideration of the duty cycle. It is 60%, that is 0.6. Okay, so we get finally in watts. Okay, right. Next, the third problem, okay, calculate the tool wear ratio. Okay, so already we have discussed that for even electro discharge machining or even for electro discharge grinding, volume of material removal from the tool or grinding wheel to the volume of material removed from the workpiece. Okay, whether it is a tool or grinding any other tool, grinding wheel. Okay, this is workpiece, this is grinding wheel or tool. Okay, here grinding wheel is the tool, that's it. Okay, so the ratio TWR is the ratio of volume of material removed from the grinding wheel, okay, by workpiece. Okay, right, that's what we have written here. Next, in problem 4, calculate the surface roughness in micrometers. Okay, so the formula is RA equal to small k into I, where k is the surface roughness, okay, I is the current in amperes. So substitute the values so that we get like this. Okay, right. And in problem 5, spark gap calculation. Okay, so for that the formula is that equal to half CV square. Okay, so where C will be given in PF, that we have to convert into STF. For that, multiply with 10 power minus 12. So with this, let me conclude. Okay, so these are the references. Okay, thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.